So now we have 10.1d. We have to discuss the graph of displacement versus time yt and displacement versus distance yx. We have two types of graph. We have graph of displacement y versus t, and we have graph of displacement y versus x. So for the graph of the displacement y against t, the value of x will be given. So then we will have y x t is equal to a sine omega t minus kx. So when x equals 0, we have yt is equal to a sine omega t. Okay, when x equal to 0. This one we have graph of y versus t. Based on equation, we have y equal to a sine omega t. So when you plot graph of y versus t, so you will have the sinusoidal graph like this. So you have one complete oscillation is our period. This is t. Okay. So now we move to graph of displacement versus distance. Based on our equation, we have y is equal to negative a sine kx, because we have, alright, so because t is equal to 0, so then we have y x equal to a sine omega t minus kx. So when t equal to 0, we have y equal to negative a sine kx. So when we have negative a, so the graph will be like this. Negative. Okay, negative. Start from negative, downward. Okay, so this is our wavelength. One wavelength for one oscillation. One wavelength. Now we look example 10.2, an ocean with crest to crest distance of lambda 4 meters. Okay, so lambda is 4 meters. Can be described by the wave function y x t equal to 0.8 sine 2 pi x over 4 minus t over 2. Okay, you have to sketch y versus x at t equal to 0. Remember that the velocity given is 2 meters per second. Okay, so we have lambda, which is 4 meters. We have the velocity is 2 meters per second. The equation given is yxt is equal to 0.8 sine 2 pi x over 4 minus t over 2. And you have to sketch, okay, y versus x at t equal to 0 second. So first we have to write the equation y x t equal to 0.8 sine 2 pi x over 4 minus 2 pi t over 2. So then you have y x t equal to 0.8 sine pi x over 2 minus pi t. And then you compare with the progressive equation where we have a sine kx minus omega t. So here, okay, so here you have your amplitude is 0.8. So your amplitude is 0.8 meters. Your k, the wave number is pi over 2. Okay, your k is equal to pi over 2 per meter. And your omega is pi radian per second. So the wave is propagate to the right because we have negative here. Wave propagate to right. Okay. So then you have to sketch y versus x at t equal to 0. So remember that you have 0.8 sine, okay, y x t equal to 0.8 sine pi x over 2 minus pi t. Pi x over 2 minus pi t. Okay, so when t equal to 0, so y x t 0 equal to 0.8 sine pi x over 2 because t is 0. So here you have to plot graph of y versus t, y versus x. Okay, sorry, y versus x. So before that you have to make a table first. Okay, for y, no, for x and for y. For x and for y. For x and for y. Okay, for x, you have to find wavelength. So how can we find wavelength? From v, velocity. V is equal to f lambda. Right, so v is equal to f lambda. So our v is 2, so we have to find lambda first. Lambda equal to v over f. Our v is 2. Our f. Okay, so how can we find f? We can find f from our omega, where omega is equal to 2 pi f, and omega here is equal to pi. So pi is equal to 2 pi f. So pi, so we have 1 is equal to 2f. So f equal to 1 over 2. So f equal to 0.5 hertz. Alright, so buat ke sini 0.5. So our lambda is 4 meter. Okay, our lambda is 4 meter. So we can plot this one and this one. So we start from origin. So 0. Okay, 1, 2, 3, 4. 2, 1, 3. Okay. So we press calculator when x equal to 0. Okay, so when x equal to 0, make sure your calculator in radian mode. Radian mode. Okay, make sure your calculator in radian mode. So you have when x equal to 0, y also 0. So this one, y also 0. When x equal to 1, okay, when this x equal to 1, so y 1, 0 equal to 0.8 sine pi 1 over 2, you will have 0.8. And then find your in your calculator, press 2, and then you continue 0.2, we have 0. Don't forget to press the calculator. So we know that we will have a sinusoidal graph. Okay, this one is 0.8 and this one is negative 0.8. Okay, so when 0, 1, 2, 3, 4. Okay, so 1 is 0, 2 is 1 is 0.8, 2 is 0, 3, negative, and you have this one. So your graph will be like this. Okay. Here is the solution process for example 10.2, where lambda given is 4 meters and v is 2 meters per second. So you have to write the equation like this: y equal to 0.8 sine pi over 2x minus pi t. So we compare with progressive way, where a sine kx minus omega t. So we can have here the amplitude is 0.8 meter, your k is pi over 2 per meter, your omega is pi radian. So then when t is equal to 0, you substitute y equal to x, 0 equal to 0.8 sine 2 pi x over 4. So when x is equal to 0, so you find that your y is equal to 0, you press your calculator and make sure your calculator in radian mode. Okay, so this is our graph. Okay, when you plot the graph of y versus x, your sinusoidal graph will be like this. And this one is when t is equal to 0.5. You substitute t is 0.5, we will have this equation: y x 0.5 equal to 0.8 sine bracket of pi x over 2 minus 0.4, 0.5 pi. So when you substitute x equal to 0 into this formula, you will have your y equal to negative 0.8. But don't forget to change your degree mode into radian mode. Okay, so when you substitute x equal to 1 into this formula, your y shows 0. Okay, so then this is your shape of the graph. The graph will be start from negative 0.8. Because when x equal to 0, your value is negative 0.8. So then, we look at question B when x equal to 2 meters. Okay, when x is equal to 2 meters, so we can have the equation when x equal to 2 meters, we have y x t is equal to 0.8 sine 2 pi x over 4 minus t over 2. So here your x is 2, so 0.8 sine 2 pi 2 over 4 minus t over 2. So y 2t, okay, so your y 2t is equal to 0.8 sine pi minus pi t. So you make a table. We have t and y. T and y. Okay. So to find t, okay, we have t is one complete oscillation where one period. We have omega is equal to 2 pi over t, and we know that our omega is pi radian per second, so 2 pi over t. So then you have your t is 2 seconds. So here your t is 2 seconds. Okay, so you have 0, 1. So this one is 0.5 and 1.5. Okay, so your graph will be like this. Y versus t, you have 0, you have 1, you have 2, and here you have 0.5, and here you have 1.5. Okay, So then you substitute the y into this formula when t is equal to 0. So when this t is equal to 0, okay, when this t is equal to 0, you press your calculator in radian mode, you have your y is equal to 0. When t is equal to 0.5, you will have your y equal to 0.8. Okay, so then 0, negative 0.8 and 0. So your graph will be like this. Okay, this one is positive 0.8, this one is negative 0.8. So your graph will be like this, sinusoidal graph. Okay, so this is your period T. Time to complete one oscillation.